Hello students, 12th class, magnetic effects of current. So in this chapter we have already done Ampere circuital law, we have already done BS law, Biot Savart law. Two very important topics we have already done. Now the third topic which we are taking up is motion of charged particle in magnetic field. Okay, so in this, Lorentz force, right, force on the charged particle entering in a magnetic field, motion of charged particle in magnetic field. So what is the force? See, memorizing the formula would be easier if you understand what are the parameters involved in that particular, right now we are finding out the force. So what are the parameters involved? If you are taking the charged particle, so obviously it would have some charge Q. If it has got some motion, it is in motion, right? So its velocity. Now you are talking about force on charged particle moving in a magnetic field. So magnitude of magnetic field is also there. Now one more thing. Force is a vector. That means if we are taking up these three, we have to have that vector multiplication of two vectors, because cross product of two vectors is another vector, that we are aware. So what we are actually doing, force on the very simple formula, force on charged particle would be equal to Q V cross B. V cross B. This is the force on this charged particle. This is charged particle, positive charge. If this is the positive charge, motion of positive charge can be considered as what? Direction of current. No, the direction of motion of positive charge can be considered as direction of electric current. So that we are aware. So we will require this particular concept, this particular concept. What concept? Direction of velocity and direction of current. Because this is not only the force on charged particle we are required to find out, we may require to find out the force on current carrying conductor in magnetic field. So there it is important to have the clear-cut direction of the flow of current. Okay, so right now focus on the motion of charged particle with velocity v and the magnetic field in which the particle is entering. You need to visualize this, and it is a three-dimensional picture, so be very, very clear about it. There are two ways to find out the direction of force. First one is cross product, another one is Fleming's left-hand rule. We will talk about Fleming's left-hand rule also, but I would urge you to, master this cross product stuff. Okay? With the help of cross product, it would be easier for you to find out the direction of force. Is that clear? So move ahead. So force is clear now. Now with this particular thing, we may conclude too many things. With this particular equation, we can conclude too many things. What? First of all, if you look at it closely and you have got the fair idea about the vector product, we may for sure find out this, that force is, this direction of magnetic force is always perpendicular to V, and it is always perpendicular to B as well, because direction of resultant vector, when you cross multiply two vectors, we have another vector which is perpendicular to the plane of the two vectors. We are aware of this. like this. If you look at it, you can hold your finger like this, okay? You can hold your finger like this. If you consider this to be middle finger to be the direction of velocity of charge particle, and index finger to be the direction of magnetic field. If you do this cross product, you have another third vector which is perpendicular to both of these vectors, right? So this is the force. So this is how the Fleming's left hand rule also is applicable here. This is Fleming's left hand rule only. Index finger shows the direction of magnetic field. This middle finger shows the direction of velocity of charge. And this thumb shows the direction of force experienced by, yes, by the charge particle. Understood? So this is how it goes. Using cross product also, if you can look into this, it is V cross B, right? So V is along x-axis, B is along y-axis if you are considering. Then what will happen? Then this force would be what? Force will be along positive z-axis, because I cross J is plus K. If you change this like this, then what will happen? If you have got this I cap cross K cap, then magnetic force will be minus J cap, that is along minus y-axis. Is that clear? So these things we have to practice properly. If you have got the idea of cross product, then that is a good thing. That is, that is good enough. You can apply the concept and get the direction of force easily. Otherwise, you need to have the Fleming's left hand rule in mind. So both the tools are applicable, right? You will get the similar result, and be very, very particular about the concepts. Okay, cross product as well as the Fleming's left hand rule. Practice properly. Before solving any numerical, just fix these things in mind. Engrave properly. Okay, now let us move. If you have a zero velocity, if particle is not moving, particle is stationary in the magnetic field, what will happen? It will not experience any force. Okay, that is there. Okay, this is clear to you? Right. Now, move on. Let us talk about some other stuff. Look at this. If the charge is at rest, then magnetic force is zero. Okay, if magnetic V and B are 0 degree, then also charge experience no force, right? If magnetic field and velocity of charge particle are parallel, then what will happen? You are aware of this fact that Q, V, B, sine theta, if it is a cross product, right? You are aware that this is Q, V, B, sine theta. If theta is 0 or 180 degree, 0 or 180 degree, F is bound to be 0. So when you say that there is zero magnetic force, what we can conclude with this? We can simply conclude that it will go undeviated in the magnetic field region, right? I believe this you are able to visualize. And this chapter or any chapter we are doing in 12th or 11th, whatever we are doing, be very, very careful about visualizing the stuff. Okay? If you will visualize during the class and after when you are practicing it, it will be a great, rewarding effort, right? You will always be able to recall the basic concepts and apply, solve problems, right? So be very careful. This is my strong urge. It is not that you need to blindly cram up the things, right? Okay, move on. So this is the stuff. When Q and B, when theta is 90 degree, then what will happen? magnetic force will be maximum. So in that scenario, what will happen? QVB will be the maximum force. At times this is also asked, what is the maximum force? They will give you the value of Q, they will give you the value of velocity, they will give you the value of magnetic field, and they will ask you what is the value of magnetic force, which is maximum value of magnetic force, right? Maximum value of magnetic force will simply be QVB, right? F max, right? Okay, now move on. This is also very important. If you are keeping the particle in a region where simultaneous electric and magnetic field are present, electric and magnetic field, right? So electric and magnetic field are perpendicular, so we can visualize this in this manner. Just have a look. This is the direction of magnetic field, this is the direction of electric field, and particle is entering, charge particle is entering along x-axis, x, y, this is y-axis, this is z-axis. So this you can visualize properly. Okay, so what we have, Lorentz force, we are aware of this fact that charge particle in electric field would experience force, charge particle will experience electric force. I'm writing here electric, electrostatic, right? Q into E vector. Magnetic force QVB, or simply Q into V cross B. So this is magnetic force. So if you are required to find out the net force on the charge particle when the particle is entering a region of, region of what? Region of simultaneous electric and magnetic field. What you will get? You will get the sum of these two forces. You will get the sum of these two forces, right? So it is very simple. This result, that means F net force will be equal to QE plus Q into V cross B. V cross B. Okay, here you need to be careful about the very basic question on this. They would ask you to find out under what condition, they will ask you under what condition. See, first of all, if you are taking up F equals Q E cap plus Q into V cross B, right? Vector E and V cross B. Now, suppose you have, as we have seen this, you have these directions. This is velocity along x-axis, along y-axis you have electric field, you have magnetic field along z-axis, right? So if you consider this, what you are going to get? E is magnitude of E and J cap, V is what? V I cap, then B is along what? B is what? B K cap. Are you aware of this? Now this is very simple. If you are given the directions of electric field and velocity and magnetic field, then finding out the direction of force would be easier, right? I'm not talking about the magnitudes as of now. I'm just interested in finding out right now the direction of net force on the charged particle, right? So let's have a look. what will happen? You have F, so QE J cap, okay? QE J cap plus QVB. These magnitudes are taken. Now V is along I cap and B is along K cap. Now what you will get? As I have told you, while starting the chapter, I have told you that this chapter requires the concepts of vector product, right? So you are aware of this, that I cross K equals minus J, right? I cross K equals minus J. What will happen? So QE J cap plus QVB into minus J cap, which gives us this very simple expression, F equals QE minus QVB J cap. Okay, now this we have understood. I have taken some arbitrary direction. You might be given some other directions, but the concepts which you have understood, you can apply to find out the result. Okay, now very important conclusion we can get from this particular equation. If this question is asked, which is more likely to be asked, under what condition charged particle goes undeviated means whatever path is being followed, it is following the same path, undeviated, in the region of simultaneous electric and magnetic field. This is the question, right? So, as we have found in this particular equation, just have a look. When you say that it goes undeviated, means it experiences zero force. So this is the answer. This is very important question, and this is asked for 1 mark, right? These days the new syllabus board, new pattern of exam requires your application skill, right? You are not supposed to just remember the formula. They will ask you the questions. You are aware of this fact that 20 questions in boards are 1 markers. Either they will give you one-liner or they will give you multiple options out of one, will be correct. So objective type and one-liner, these sort of questions would be there for 1 mark. So be careful. Whatever you are going through, whatever you are understanding, you need to apply. What is it? Okay, so here what we have understood, if you say that F should be 0, so what is that? F is 0 means QE minus QVB J cap. You may understand these directions, V, this is E, and this is the direction of B, X, Y, G, right? So in the given situation, this is the expression. Now force to be 0, what will happen? QE equals QVB. Okay, that means electric field equals velocity into magnetic field. This is the condition. This is the condition. Okay, this is the condition under which the particle will go undeviated in the region of simultaneous electric and magnetic field. So this condition is very important. And while learning this electromagnetic wave, this equation is very important, right? If you think of it, you may consider that E electric field equals C into B. In electromagnetic wave, electric and magnetic fields are oscillating. Electric and magnetic fields are oscillating, then electromagnetic wave is produced. When electric and magnetic field are oscillating, electromagnetic wave is produced. And what is the velocity of electromagnetic wave? It is same as that of the light, right? Light is a electromagnetic wave. So the scenario is this: you will replace this v by the velocity of light. In that scenario, what will happen? Direction of C will be this. C into B will be equal to electric field. This is the maximum value of electric field. This is maximum value of magnetic field. So this concept is required. When you will understand the basics of electromagnetic wave, you would require this relation. So if you have understood this properly, this is applied in that particular chapter. So be careful. Okay? All right. Now what we can do? Come to this again. We have understood this fact that when electric and magnetic field both are present, electric and magnetic field both are present, the force on the charged particle will be due to the electric field and due to the magnetic field, and you add them up, right? So there is condition when the net force is 0, and what is that condition? Condition is electric field should be equal to velocity into magnetic field. If this condition is satisfied, then net force on the charged particle will be 0. So this is very important conclusion, right? Okay, now let us move on to the next topic, next conclusion. Okay, yes, this is also very important. Now again, come back to the magnetic force. In this, if you can look at it, magnetic force is always perpendicular to the direction of velocity as well as magnetic field. The particle describes circular path. Oh, this is very important. This is very, very important. What is happening? Just have a look. Just have a look. You are saying that force, this magnetic force, again I'm coming back to this magnetic force only. Okay? So Q V cross B. Q into V cross B. What is it? Pay close attention. Force is always perpendicular to velocity. Now, we know that if force is always perpendicular to the direction of velocity, then what will happen? There's this sort of stuff. This is velocity, this is force, all right. Again, here, this is velocity, this is force. Here, this is velocity, this is force. So what did you observe? It is always perpendicular to velocity. Here, if this is velocity, then this is force. So one force is always acting towards the center, and that makes this particle describe the circular path, right? Is this clear or not? When force is always perpendicular to velocity, the particle is bound to describe the circular path. All right, this is important. Now, this is one conclusion. Another conclusion: work done by magnetic force is 0, because magnetic force provides magnetic force provides the centripetal force. The centripetal force. Magnetic force provides centripetal force, due to which due to which the particle describes circular path. Due to which particle describes circular path. Right? Now, circular path, will it be clockwise or anti-clockwise? That would depend upon the direction of magnetic field. If it is into the page, in the region, and the charged particle is entering in particular direction, according to that, whatever basic idea will give you with this expression, with this expression we can find out the direction of the sense of circular path, clockwise or anti-clockwise. That would depend upon this particular equation. So we will take up that also example. Now, so centripetal force, if you are saying velocity is also along this, so it is quite obvious that displacement will also along this. So velocity and displacement both are perpendicular to the force. When you have got work done, you have to find out work done. Work done equals F into D into what? Cos. FD, cos D is displacement here. Cos 90 degree. So what will happen? It will be 0. So work done will be 0. Is that clear? Okay, now let us move on to the next stuff. Next important point. Kinetic energy of the charged particle is constant. Kinetic energy of the charged particle in magnetic field, in uniform magnetic field obviously, will be constant. Why so? Just have a look. We understood that since velocity and displacement are perpendicular to the direction of force, work done is 0. Okay. So from work energy theorem, work equals change in kinetic energy. Change in kinetic energy. So what you are saying? Work done is 0. Work done is 0. That means this is change in kinetic energy. So change in kinetic energy is 0 means what? Change in kinetic energy is 0 means what? Work done is kinetic energy is constant. So when change is 0, the kinetic energy is constant. Ke, kinetic energy, is constant. Understood? So these are the conclusions. See, this is our required approach. When we see some equation, we got this equation, we need to conclude it. We have this awareness that what happens if force is always perpendicular to the velocity. We have this idea. Based on that, we will come to some conclusion. Based on that, the next conclusion and further conclusions. So all these points, you don't require to memorize blindly. What you need to do is, with this particular equation, we may come to these conclusions. Okay? So this is what I think you must practice. Okay, this is the equation. If we arrive at this equation, we may conclude something based on this particular equation. If you inculcate that habit, trust me, what will happen, you will have to put in less amount of effort and you will be so effective while applying the concepts, while solving problems. You will always excel, right? Because blind retention is not going to help you in any way. Okay, right? So this is the conclusions of that particular equation. Okay, next. In the next topic, what we are going to do? Yes, this. If cos theta, if theta, what is theta? Theta is the angle between what? Electric field and velocity, electric field and velocity. Just have a look. This is into the page. You can see it into the page. That means velocity is magnitude, and what is the direction? Minus k cap. Okay. Now what is the direction of velocity? If you consider this is the direction of velocity. So v is along I cap, along x-axis. Now what is the force? What is the force? You have force equals Q into V cross B. Be very careful here. We need to understand, if you have got positive charge, if you have got negative charge, do you think the direction of its circular path will change? Yes, it will change. Just have a look, you will understand. So let us take this magnitude outside. Okay, so V is along along x-axis. This I cap cross minus k. I cap cross minus k is what? J cap. So Q V B J cap. That means it will go along this path. It will follow this path. Understood? Now when it comes here, now the velocity becomes this. Velocity comes in this direction. That means J cap V Q V B. If it is coming here, then the direction of force will change. Direction of force will change. In this condition, Q V B will be equal to what? J cross minus K. So this is obviously Q V B. So along negative x-axis, that means force will be directed in this direction, right? So this is what we need to keep in mind. This is how we can figure it out, that this is going to have this anti-clockwise direction if condition is such. Now, if you think that this charge particle has got a negative charge, if this is negative charge, then this is going to be what? Minus J. In that scenario, what will happen? Rather than following this path, it will follow this path. Rather than this path, it will follow this path. So electron in this scenario, in this scenario will follow this path. This path. Electron will follow this path. Right? Electron will follow this path, opposite. Why so? We are aware of this. If it is positive charge, you are saying F equals Q V B J cap. In this direction, if it is following this path. So if Q is minus E V B J cap, that means along negative y-axis. Okay, so this is the thing. One more thing which we need to understand, if you have got 90 degree, then force is what? Then force, magnetic force will be QVB. Force will be QVB, and since that magnetic force is providing centripetal force, so QVB equals mv square by r. And with the help of that, this radius of the circular path can be found out. Right? Okay. So in the next chapter, in the next session, we will understand many other parameters, how to find out with the help of this particular equation. Okay, there are questions based on this, so many other parameters, and we will also learn the force on current carrying conductor in magnetic field. So this is the end of the session. In the next session, stay tuned, work properly. Whatever we have done, these have got applications in the next topic, so be very careful. Okay, practice properly. Thank you. See you in the next session.